Hi, this is Mike, not Miss Riggins, on 4.5 Applications to Marginality. As you're watching the video, please don't fall asleep and try to take notes on the concepts that I'm explaining, and then at the end of the video, answer the questions that are here to see and check if you clearly understood the concept and material well. My voice might not be as interesting and fun as Miss Riggins, but I'll try my best to make this video not sleepy. Okay, let's begin. Okay, so first let's talk about cost and revenue. So cost function is written as C of Q, and it's the total cost of producing a quantity Q of some good. So in the firm's perspective, it's the total amount of money you need to produce the certain amount of goods. And of course, the cost function is an increasing function because you need more money to produce more quantity of goods. For instance, you need more money to produce 10 teddy bears than to produce 5 teddy bears or 2 teddy bears, and so forth. And here in the graph, the y-intercept represents fixed costs, and fixed costs are costs you need when producing zero amount of goods. So fixed costs can be management costs and so on and so forth. It's the cost you need when producing Q when Q equals 0. And as you can see from the graph here, first it's concave down, then it moves concave up. This is because that producing larger quantities of goods is more efficient than producing smaller quantities of goods. But later on, as you produce too much, because resources are scarce, the costs of producing the goods would increase sharply. And then the revenue function is the total revenue received by a firm from selling a quantity Q of some good. So revenue is good for the perspective of a firm. And you get revenue by multiplying price and quantity. So if you look at these two graphs, they're both graphs of revenue, but the only difference is that the first graph, the revenue is constant, meaning the price is constant as the quantity sold is increased. However, as quantity increases, the price decreases. That's why the revenue also decreases, because price and revenue are directly proportional. And this happens in like the real world, because as you sell more, the scarcity or like the rarity of the product is decrease. That's why people don't want to buy it anymore. That's why the price is naturally lowered. So, however, what firms are interested in is in the end profit, and you calculate profit by minus revenue minus cost, and you write profit as the symbol pi, and this is to distinguish profit with price, because price is written as p. So if you write profit as p, then we'll get confused. So if you look at this graph, for what production quantities does the firm make a profit? And to make a profit means to have a revenue has to be higher than cost, right? This means that in the graph, the part where revenue is higher than cost is between 130 to 215, right? So this is where they make profit. How about here? How about this part? And this part where cost is higher than revenue, then profit becomes negative, and that becomes a loss. But the interesting point here is that when revenue equals cost, the profit is 0, and this in economics is called normal profit, just for your information. And in economics, normal profit is also a good thing, but I don't know about in calculus. So now that we know the basics of revenue and cost, we'll go into the hard part and the focus point on this chapter, which is the concept of marginality. So our econ textbook states that economists think at the margin, and margin, as you guys know, mean at the edge, at the border. And what does this mean? Well, the best way to explain this is by telling you the definition of marginal cost and marginal revenue first, and then explaining further on. So marginal cost is the additional cost of producing one more quantity, And marginal revenue is the additional revenue gained from producing one more. So let's look at the next page. Here we have a graph and let's say this firm is producing teddy bears, and the total cost of producing 99 teddy bears is $240, and producing one more becomes $260. Then marginal cost, as I defined, the additional cost of producing one more quantity is $20, and it's the same thing for producing one more, it's $30, and producing one more, 350 minus 290 equals $60. Marginal revenue is the same thing except it's in revenue. So the total revenue of producing 99 teddy bears is $700, and producing one more, you get additional $50 revenue, and producing one more, you get additional $60 revenue, and so on and so forth. Now, marginal cost and marginal revenue can be a negative value. The total cost might decrease as you produce more, and total revenue might decrease as you produce more. It's not always positive. It's just that the example is only positive. And oh, look, marginal costs and marginal revenue are same. We're going to look in the future part what this symbolizes. So now that we looked at the concept of marginality numerically, let's look at it graphically. Okay? So looking at this graph, this is the additional cost that's used to produce one more unit, for 100 units to 101 units. And this slope, which is C101 minus C100 over 101 minus 100, which is 1, equals the average rate of change, and this represents marginal cost. But because the slope is not changing very fast near these 2 points, this is similar to the instantaneous rate of change at that quantity. And economists, therefore, because the graph isn't that radical and because the graph isn't changing that fast between these 2 points, they define marginal cost as the instantaneous rate of change with respect to that quantity. So here, marginal cost is the derivative function at that point, and marginal revenue is the same thing, the derivative of the revenue function at that quantity. And this is just what I explained before, the cost and revenue that's needed and that's gained from producing one more additional units. As you can see, Q plus 1 minus Q equals 1. So here is a very, very nice summary. Marginal cost and marginal revenue equals the average rate, and economists define this as also as the instantaneous rate of change, which is the derivative function. So look at these two functions. This is the revenue graph, and this is the cost graph that we've seen before. To find the marginal revenue and marginal cost of these two graphs, how do we do it? It's so simple. We just need to draw the derivatives of these two graphs. And look, ta-da! So simple, right? As long as you don't know as long as you know how to draw a derivative graph, figuring out marginal revenue and marginal cost is super easy, whether you have to do it graphically or analytically using equations. So now that we looked at the concepts of marginal revenue and marginal cost, let's go on to the final part, which is to learn how to maximize profit. So all the firms are seeking profit, and it's better to have more profit than less profit, right? So we're going to look at two ways. We're going to look at how to find points that maximize profit graphically and analytically using equations. So looking at this definition and looking at this function, we can see that from this section to this section, because revenue is bigger than cost, it's encountering a profit. But however, in these sections, in this section, sorry, I'm a terrible drawer. In these sections, it's encountering a loss or a negative profit. But from here, because profit is defined as revenue minus cost, if revenue is a lot more bigger than cost, then it's is probably maximizing profit, and from here it's clear that this difference is the biggest among all the differences, and this point, which is quantity of 140, is where they maximize profit. Now we looked at this graphically, now let's look at it analytically. But before we go on, just look at this point. What do you notice about these 2 points? And if you're smart enough like me, you'll notice that the slope at this point, the slope of the tangent line, is actually the same. And as I said before, the slope of the tangent line, the instantaneous rate of change at that point, is the marginal cost and marginal revenue. See, so you guys are getting the hang of it, right? The maximum or minimum profit can occur when marginal cost equals marginal revenue, like we've seen before on the graph, when the two slopes of the tangent line are the same. That's why I said before, when we looked at the chart, that when marginal revenue was equal to marginal cost, it was interesting, right? That's the profit maximizing point. And to find and the tips for finding the maximum profit quantity is to find MR equals MC and determine the profit maximizing point, and it's probably the local maximum and local minimum. However, you also have to consider the endpoints and have to consider the global maxima and minima. So from this graph, we have to also check the endpoints of the interval to see if they represent the global maximum or the minimum, because this might not be the global maximum or minimum, right? Okay, so this is end of my teaching you the concepts. Now let's solve 2 problems together to see if you guys understand. So a car wash operator pays $35,000 for a franchise, then spends $10 per car wash, which costs the consumer $15. Here, $35,000 is the fixed cost, because even if you don't wash any cars, you still have to pay this for the franchise. And $10 per car wash is what we call in economic terms the variable cost. So the cost function is 35,000 plus 10Q, where Q is the quantity of cars washed. And the revenue function is 15Q because for example, if you wash 4 cars, you get $60 because 15 times 4 is 6. The second problem, revenue is given by this function and cost function is given. At what quantity is profit maximized? There are 2 options of solving this. You can draw a graph of revenue and cost, and you can find out where the slope of the tangent line is equal to, but because that's hard, let's just do it numerically, analytically. So marginal revenue is the derivative function of revenue function, and the marginal cost is the derivative function of cost, and it's equal to these 2, right? Profit maximizing when these 2 are equal, so it's when Q equals 75, then marginal revenue is equal to marginal cost. So at quantity equals 75 is profit maximized. Now to find total profit, as I said before, profit is revenue minus cost. So total profit is the revenue when produced 75 quantity minus the cost we need when produced 75 quantity. Okay? So that's the end of the video. So feel free to go back and rewind the video and pause at moments where you didn't understand, and also feel free to ask me questions about the concepts you didn't understand, okay? And make sure to solve the practice problems that are in the textbook, okay? Bye! It's over! It's over!